We're going to work through these next few questions. Number 26 and 27, it says classify a triangle with the following side lengths as right, acute, or obtuse. Explain your reasoning. Well, first let's talk through the reasoning. So we learned if we take the longest side squared and compare it to the sum of the squares of the smaller two sides. So I'm just going to put small side 1, a little subscript of 1, and we're going to square that, plus the other small side, so a little subscript of 2 squared. And so we're going to do that if the longest side squared is less than, so I'm going to fill in the blank. So if less than, then it's an acute triangle. If they're equal to each other, then it's a right triangle. And if the longest side squared is greater, then it is an obtuse triangle. So make sure you square the things like you're supposed to. So let's just see if we can fit these over here on the side. We'll do 26. So 26. I'm going to take the longest side squared. So it's important to have the longest side on the left in order for this to work with these signs. We still could think through them with the concept and figure them out. So 26, the longest side squared is 27. So we're going to compare 27 squared to the shorter two sides. So 10 squared plus 24 squared. So we need to figure out a few of these things. 27 squared. We know 10 squared is 124 squared. So 27 squared from the calculator, we know that is 729. And we want to compare that to 100 plus 576. Well, if you add those together, that only gives you 676. And so it's definitely 729 is greater. And if we look at our key over here, we know that that is going to be an obtuse triangle. And then for 27, you do that similarly. You take your longest side squared, so 41 squared, and we're going to compare that to the sum of 40 squared plus 9 squared. So again, we'll find a few of these things. 41 squared is 1,681. And we're going to compare that 40 squared. That's pretty easy because 4 times 4 is 16. So that's actually 1,600. 9 squared we know is 81. Oh, and it happens that it is the same. Well, 1,681 equals 1,681. And so we know, since they are equal, that it's a right triangle. All right, moving on to number 28 and 29. These have to do with our special triangles. So let's review that. So our special triangles, actually we'll just write them. So we have the 45, 45, 90, also known as right isosceles. We learned that the hypotenuse is always it's always the leg times the square root of 2. That's the main formula. We also talked about that the leg always ends up being half the hypotenuse times the square root of 2, which is also pretty helpful. And so in this case, we know the hypotenuse, and so we can find d. So the hypotenuse, the leg, what we're going to find is d, so we're going to use this formula, although you could plug it into the other one and solve for d, but we know that d equals half the hypotenuse, so half of 6 times the square root of 2, and so this is 3 times the square root of 2. If you don't want to memorize both those formulas and just know this one, what you would do is the hypotenuse, you could plug the hypotenuse is 6, the leg is d times the square root of 2. We would have to divide both sides by the square root of 2. Another probably Algebra 2 topic is that you can't leave a square root in the denominator, and so we call that rationalizing the denominator, and all we do is multiply by the square root of 2 over the square root of 2. The reason we do that in the denominator, square root of 2 times the square root of 2 is just 2. In the numerator, we have 6 times root 2. That reduces, and we get d is equal to 3 times the square root of 2. So that was a review of 45, 45, 90. We also have 30, 60, 90 triangles. So 30, 60, 90, we had a couple equations for that as well. Actually had 3, but 2 main ones, and that was that the hypotenuse equals the short leg times 2. And we learned that the long leg equals the short leg times the square root of 3. And so in this one, to find x, that's the hypotenuse. So the hypotenuse, we'll use this formula right here, is simply equal to the short leg, 2 times the square root of 3, times 2, which gives us 4 times the square root of 3. And then to find y is the long leg, so now we're using the bottom equation. The long leg, y, equals the short leg, which is 2 times the square root of 3, times the square root of 3. Well, the square root of 3 times itself, square root of 3 times the square root of 3 is just 3. And so y equals 6.